All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of tutorials. If you haven't already, subscribe to the channel and leave a like for this video. Now, in today's lesson, we're going to answer this question that I gave my students as a quiz. So the question asks for the voltage on each resistor. So on each of these resistors, what will be the voltage? And the current on these two ammeters if the switch, which is switch 1, is open, and case 2 if the switch is closed. Now this was a fairly simple question. We can start with if the switch is open. So if the switch is open, meaning that this ammeter will have no reading because there is no connection with the other part of the battery. Okay, so we can start there. So if this switch is open, we know that the reading on ammeter 2 will be 0 amps. Okay, and how will current travel? So the path that current will take is this path here. So the red line is the current, or the path that current is taking. So it will go through there. So it will take that path until it reaches the negative terminal here. So no current will go through here because this one is open. So that will be the path that current will take. So meaning that if we can find the current, the total current, which is the current that will go through this ammeter, then we've found the current that will go through ammeter 3. Okay, so let's find the total current. So total current is equal to the voltage total, which is the EMF, or the voltage of the battery, divided by the resistance total. Okay, so the voltage of the battery is 8.1 volts. And what about the resistance? So the resistance total will be these resistors, and we see that since this is making a series circuit, so the resistors will just be the sum of the resistors. So this will be 7, which is this, plus 20, plus 12, plus 14, plus the 3 ohms, and this will give us a total resistance of 56. Okay, so 56 ohms because this is a series now, and we just put 56 there. So 56 ohms, so this is equal to 0.1446 about there amps. So that would be the total current, and since the total current is the current going through this ammeter, that will be the reading of the ammeter. Remember, the ammeter reads current, so that would be 0.1446 amps. So that will be the total current for a situation when the switch is open. Okay, so now we have our current. We can find the reading of the voltmeter on these resistors by simply using the formula voltage is equals to current times resistance. Okay, so we know the current that is going through there, 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 and that is going through there. So we can easily find the voltage by multiplying with the resistance. So for the first one, current is the same current that is going through everywhere here, which is 0.1446 times, what is the resistance there? 7. So when we multiply this out, we can say this is voltage 1. So this will give us 1.0125. So voltage 1 is the voltage of the 7 ohm resistor. This is resistor 7, so this is 1.0125 volts. Okay, we can go to resistor 6. Resistor 6 is this resistor here. Since there is no current that is going through here, So current will be 0 times the resistance, which is 14. So 0 times 14 will give us 0. Then here there is no current going through this path on resistor 5. So voltage will be equals to current times resistance. Since current is 0, so 0 times 7.5 will also give us 0 volts. Then okay, will also give us 0 volts. Then we go to the 4 ohm the resistor 4, which is the 20 ohm. So 20 ohm resistor, we know the current that is going through there is this current. So this will give us this. Same applies on the resistor 3. Resistor 3 is this one. We know the current that is going through there. The current going through there in red is this one. So current times resistance. So that would be, so when we get the voltage here, we know that current is this one and the resistance is that one. So when multiply to find the voltage, we're going to have 0.4339. Okay, so this would be the voltage on each of those resistors. So the key here is just finding the current that will go through each of those resistors. And if an ammeter is in the way of that current, then that current will show in the ammeter. So for instance, our current was taking this path, and it's this current that went through the ammeter. So the ammeter will show that current there. So now to find the voltage on each of those resistors, we just need to know the current going through there. And since we have the resistance, we can say current is equals to, voltage is equals to current times resistance. So to find the voltage there, you just get the current that is going through there and the resistance, which is 7 ohms. Same applies here. We know the current that is going through there is this one times the resistance will give us the voltage there. Same applies here. To find the voltage there, you'll say voltage is equals to current. We know the current going through there and times the resistance that will give us the voltage there, and so on and so forth. Okay, so this is the case if the switch is open. So now let's look at a case when the switch is closed. All right, now for the case when the switch is closed, so the current here has a path that it can take. So the switch is closed, so meaning that this part here is closed. So current, when it starts as total current, I'll put total current in red. So when it starts as total current, when current reaches a junction, on that junction it will split. So there will be some current that will go in this direction. So this direction, that will be the current that will be right there, and that will be the current that will be right there. Then there will also be some current that will go in this direction down here. Okay, and that will be the current that will be right there. Then when these currents rejoin, they form the total current again. Okay, because they started out as total current. So they rejoin as total current. So we can call this the total current. We can just say total current. Then we'll call this current in black as current 2. And in green, we'll call it as current 1. Okay. So now, for us to know the voltage that will be read there, we can just find the total current first of all. So we just find the total current, and the total current is going through there. It will give us the voltage that is there, since we know that voltage is equals to current times resistance. So if we find the total current times this resistor, it will tell us the voltage that is there. And remember, since this is um, from the 8-volt resistor, we can tell the voltage that will go there and there, since voltage in resistors splits evenly on parallel circuits. Okay, we'll see that just in a minute. So let's find the total current. So for us to find the total current, first of all, we need the total resistance. Okay, so the total resistance will be this resistor, which we're calling resistor 7. Resistor 7 plus these resistors that are in parallel. Okay, we can just say resistors in parallel. Okay, so we can find the total resistors for the resistors in parallel. So I'll say resistor A, these resistors are in parallel. So these, first of all, are in series. You see that these are in series. So that is 20 plus 12 plus 14 plus 3. So these are in series, so we can add them, which will give us 49. So this will be 49 ohms. Then these are also in series. We call them resistor B, which is just 7.5 plus 14. So which will give us 21.5. Okay, so so this is resistor B. Okay, so for these resistors that are in parallel, we'll just say resistance in parallel total will be, we can just say RA times RB divided by RA plus RB. Okay, so this is the shortcut formula for finding the total resistance in parallel. So this will be RA is 49, so that is 49 times 21.5 divided by 49 plus 21.5. Okay, so when we sum that, let's see, 21.5. So simplifying that, the resistance in parallel, so resistance in parallel, total resistance in parallel will be equal to 14.943 ohms. So this is the resistance in parallel. So we said the total resistance will be this resistor, which we can call it resistor 7. So it's resistor 7 plus the resistance in parallel. So our total resistance total will be equals to resistor 7, which is 7, plus the resistance in parallel, which is this one here, 14.943. So we add that, we're going to get 21. So we get resistance total, which is equal to 21.94326. Okay, so this is the resistance total of this circuit. So we can finally calculate the total current since we have the total resistance. So we can simply say current total is equal to, let me write it here, current total is equals to voltage total over resistance total. Voltage total is the voltage of the battery, which is 8.1, divided by the resistance total, which is 21.9. So the current total will be 0.0369 amps. So that will be the current total. Now we've found the current total. We can find the voltage there. Okay, so we can find the voltage there. So we know voltage on 7 ohm resistor, so this is the 7 ohm resistor, be equal to, or voltage on resistor 7 will be equal to current going through there, which is the total current, times the resistance there. So the resistance there is resistor 7. So, sorry, resistor 7. So current, which is 0.369 times resistor 7. Resistor 7 has a 7 ohm resistor. So we can just say times 7. So this will give us 2.583. Okay. So on resistor 7, you can start on resistor 7. The voltage that will be there is 2.3 volts. So that will be the voltage there. So now, since we know the voltage that will be here, we know the voltage that will go this side and this side. Because remember, voltage only changes when it reaches a resistor, but it is distributed evenly. Subtract this voltage from the total voltage to know the voltage that will go this side and this side. So we say minus 8.1, which will give us the voltage that will go this side is 5.516. Same applies to the voltage that will go this side is 5.516. Okay, so that will be the voltage that will go through there. So now we can find the current, this current, considering the total resistance. So let me just erase this. Okay, so to find the current that will go through this path, we can just say total current that will go through this path will be equals to the voltage that will go through this path divided by the total resistance in this path. Okay, remember current voltage over resistance. So the total current in this path will be equals to the voltage in that path, which is 5.51, divided by the total resistance in that path. So the voltage in this path is 5.516 volts, divided by the total resistance in this path, which is just the sum of these, 21.5. When we divide that, we're going, when we divide 5.516 divided by 21, we're going to have 0.2565. Okay, so this is the current that will go through this path. So just say amps. So this is the current that will go through this path. So we see that this current will pass through here and go through there. So we can find the current there. So the current there will be this same current on the 2 ohm resistor, that 2 ammeter 2, that will be 0.2565 amps. Okay, then we can also find the voltage here. Since we know the current that will go through there, we can find the voltage here. So voltage is equals to current times resistance. We know the current, which is this current, times the resistor there, so times 14. So on resistor 6, the current will be 3.59. So that will be the voltage there. So we just say current times resistance. Then on the other one, current is voltage. Current is voltage over resistance. Voltage is equals to current times resistance. So the current we have, which is this current, times the resistance there is 7.5. So when we multiply that out, it will give us 1.7959 volts. Okay, that is this path. Then on this path, to simply find the current that will go through this path, we know that total current is equal to the current that it splits into. So it splits into this current plus that current, so which is just current 1 plus current 2. So we can use this formula to find the current that will go through the other path by simply saying total current. We know the total current is, we found it somewhere down here, is this one, 0.369 will be equals to current 1, which is what we are looking for, plus current 2, which we found here, which is 0.2565. So it's just transposing this, and current 1 will be equals to this minus this, so which is 0.369 minus 0.2565, which will give us 0.1125. So that will be the current that will go through this green path here. So you can find the voltage. So on this ammeter, we know the current that will go through there. So we can just put the current that will go through there is this current, which is 0.1125. So this is the current that will go through this ammeter here. So now again, to find the voltage on each of these, we know voltage is equals to current times resistance. So the current we have going through this path times the resistance there is 20. So current is this one times 20 will give us 2.25 volts. Same applies here. We have the current that will go through here is this one here times the resistance. So we just say times the resistance, which is 12. So times the resistance, which is 12, this will give us 1.35. Same applies here. Voltage is current times this current that will go through there, which is this one. So times the resistance there, which is 14, which will give us 1.575. Same applies here. We know voltage is current times resistance. We know the current times the resistance there is 3. So the resistance there is 3. So times 3 will give us 0.33. All right, so this is how you are supposed to work this question out. I hope you've had an understanding. In case you didn't understand, you can reach out to me. My contact is in the description or in the bio. Have a great evening.